Hello. Today we're going to try to answer the question, how do we take square roots of negative numbers? You see, if you were solving the equation negative 3x squared equals 3, you would divide both sides by negative 3, trying to get x squared by itself. You get x squared equals negative 1. And then in the next step, you would take the square root, but, whoa, we run into a problem. Like, what do we do here whenever we have the square root of a negative? Well, mathematicians took care of that. You see, they created an expanded system of numbers using the imaginary unit I. I is equal to the square root of negative 1. So looking back at this problem, this solves down to x equals plus or minus I, since I is the square root of negative 1. This also brings up the question, what does I squared equal? Well, let's think about it. If it's I times I, that'd be the square root of negative 1 times the square root of negative 1, or the square root of negative 1 squared, which is just negative 1. We're going to use this a lot later in a different lesson. All right, but let's see how we use I. We can use I to write the square root of any number. Check out the square root of negative 3. Well, we know by our product rules with roots that this is just the square root of negative 1 times 3. Or I could even break that up. That's the square root of negative 1 times the square root of 3. And the square root of negative 1 is I. So I can pull an I out. This is I, square roots of 3. So anytime you have a negative root, just pull an I out of that square root, and then whatever's left inside will turn positive. And at this point, I'd also like to point out that I is, called the imaginary unit, but it's only called imaginary because it is not in the set of the real numbers. This isn't like an imaginary friend or something that, real numbers have and they play with. These have practical uses, mostly in circuits and things like that, and in black holes, but we can talk about that later. I want you to try to simplify these square roots using the same rules that you already know, but now since they're negative, you have to pull an I out of the root. All right, so pause the video and give these a shot. All right, whenever we simplify these, we can just break them down into their biggest perfect square that's inside and this negative 1. So the negative 1 gets pulled out as an I, and the square root of 4 is 2. We're left with a 7 underneath the radical. And the next problem works the exact same way. The negative 1 gets pulled out as an I. The square root of 25 is 5, and we're left with a 3. In the last one, negative 16, or the square root of negative 16, the negative 1 gets pulled out as an I, and the square root of 16 is 4, so we don't even have a radical left over. All right, but now let's try to use those same rules to solve a quadratic equation. So here I'm going to try and get my x squared by itself. I'm going to subtract 11 from each side. Get 2x squared equals negative 48. And then we'll divide each side by 2. So x squared equals negative 24. And then anytime that I bring in this square root, I've got x equals plus or minus. Right? Now let's think about the square root of negative 24. That would be the square root of negative 1 times 4 times 6. So I can take the root of negative 1, which is I, and I can take the root of 4, which is 2. So those come out, 2i, and I'm left with square root of 6. So now you give it a shot on 5x squared plus 33 equals 3. All right, after going through all the steps, you should come down to find, all right, we got a square root of a negative, so we know we have an I outside the square root. And there are no perfect squares in 6, so we get x equals plus or minus, don't forget those, I square roots of 6. All right, so if you're going to have a new system of numbers, you know, these imaginary numbers, then you have to be able to perform operations with them. First, I'd like to talk about what a complex number is. A complex number is a mixture of real and imaginary numbers. It's written in the form a plus bi, where a is the real part and bi is the imaginary. If you just had an a, that's what we're used to. Those are the real numbers. And if you don't have an a and just this bi, that's called a pure imaginary number. But whenever they're together, they're called complex numbers. In this video, I'm going to focus on how to add and subtract complex numbers. And to do that, all we have to do is add or subtract their real and imaginary parts separately. So let me show you what that looks like. If we had 8 minus I plus 5 plus 4i, these parentheses actually don't even need to be here. But we're going to add their real parts, so this 8 and 5. So we have 8 plus 5. And then we have plus a negative I and a 4i. So these two things added together, 8 plus 5 is 13. Negative I plus 4i is positive 3i. The only thing that you need to be careful of is whenever you're subtracting, like take this example. 7 minus 6i minus the whole quantity, 3 minus 6i. You need to remember that you're subtracting this entire quantity, so you can go ahead and distribute out that negative if you'd like. So that'd be negative 3 plus 6i. So we have 7 minus 3 minus 6i plus 6i. These cancel each other, and you're left with 4. All right, finally, I'd just like you to try to do these two problems. Just try to add and subtract these complex numbers. Pause the video, and we'll see if you get it right. All right, for the first problem, you should have got 3 plus 6i. And the only tricky thing in the second problem is that you remember that you have to change this to a positive 2i. So 3 minus 8 is negative 5 plus 9i. So to recap what we've learned today, not only did we learn how to take a square root of a negative number by simply introducing the imaginary unit I, we also learned what a complex number was and how to perform these simple operations with complex numbers. So pretty good day. All right, goodbye.